Welcome to the deep dive. Today we're tackling Aleo. It's a layer 1 blockchain, and it's generating quite a bit of buzz.
Especially if you're someone who's, already working in the Ethereum space, building things there.
Exactly. So think of this as your introduction, your guided tour, if you will, to get a handle on what Aleo is doing differently.
Yeah, our goal here is really to give you that foundational understanding. You already know blockchain basics, Ethereum.
Right.
Aleo adds this really core privacy layer. That's the key shift. We want to help you build a mental model for it.
Okay, let's maybe start with an analogy then. Think about the early internet.
Oh, yeah. Wild West days.
Totally. Everything was just out in the open.
Yeah.
Sending anything sensitive felt, well, risky.
Like shouting secrets across a room,
Yeah,
basically.
exactly. Then HTTPS came along, that lock icon. Suddenly, secure online banking, shopping, it became possible.
That's a really spot-on way to think about it. A lot of today's public blockchains are kind of like that early internet for data, very open. Aleo, using these things called zero-knowledge proofs, is basically aiming to be that HTTPS for Web3.
So verifiable stuff happens on the ledger, but the sensitive details, they stay hidden.
Precisely. You prove something is true without showing the something itself.
Okay, so boiling it down, Aleo is permissionless. Anyone can join. It's programmable. You could build dApps.
Standard blockchain stuff there.
But the big one is privacy. Baked in from the start, not an add-on.
That's the core mission we're unpacking today. How do they achieve that privacy and keep the programmability?
Right. How do you get both?
And it really comes down to this idea, privacy-preserving smart contracts.
Okay.
Think Ethereum's programmability, but combined with the kind of transaction confidentiality you might see in something like Zcash.
So you can build complex apps, but the user data, the transaction specifics, they're protected by default.
Exactly. Protected by default, users get to choose what, if anything, gets revealed.
That sounds powerful. But how do you make that accessible for developers? Zero-knowledge cryptography sounds intimidating.
It definitely can be. And that's where Leo comes in.
Leo.
Yeah, Leo is Aleo's own programming language. It's domain-specific, built just for writing these private applications.
So it simplifies things.
Hugely. The whole point of Leo and its compiler is to abstract away a lot of the really complex crypto math. So you, as a developer, can focus on their application logic without needing like a PhD in cryptography. It lowers the barrier to entry significantly.
Got it. Easier to build private stuff. What kind of apps does this actually enable? What becomes possible that maybe wasn't before?
Oh, a whole range of things. Think about DeFi, right? Truly private DeFi, where your trades, your portfolio size, it's all confidential.
Okay. No front running, things like that.
Potentially, yeah. Or imagine on-chain games with hidden information, like poker, where your hand is actually secret on the blockchain. Or strategy games.
Battleship on the blockchain.
Kind of, yeah.
Wow.
Or think about privacy-preserving machine learning, training models on sensitive data without ever exposing the raw data points.
Okay.
And a really big one is digital identity, things like ZPass, which Aleo is developing.
ZPass. Tell me more.
It lets you prove things about yourself like, I am over 18 or I live in this country without revealing your actual birth date or your full address, just the proof.
That's huge, proving just what's necessary. That feels like a real game changer for online interactions.
Definitely. But yeah, this tech didn't just appear overnight. There's a history here.
Right. Where did it come from?
The core concepts really trace back to a research paper from 2018 called the ZEX White Paper.
ZEX?
Yeah, Z-E-X-E. It laid out this theoretical framework for a blockchain combining ZK proofs and programmability.
And who are the key people behind turning that idea into Aleo?
A pretty impressive group. Howard Wu, Sean Bo, Alessandra Chiesa, Matthew Green, Ian Mears, Pradesh Mishra. A lot of names you'll see at the forefront of ZK research and projects like Zcash.
Okay, serious crypto expertise there. What was the timeline like from paper to now?
Well, the first testnet and an early version of Leo Studio, their IDE, came out in 2020, kind of an initial proof of concept.
Getting developers involved early.
Exactly. Then a big milestone was the MPC setup ceremony in August 2021.
MPC, like Zcash did, for the security parameters.
Precisely. A big community effort to generate the public parameters needed for the ZK system, ensuring no single party could compromise it. Thousands participated.
Okay, crucial step. What came next?
Testnet 2 launched later in 2021. That's when provers, the people generating the ZK proofs for the network, could actually start earning Aleo credits. It also included an upgrade to the consensus called ACERT.
So, incentivizing participation, refining the tech.
Yeah. And then testnet 3 in 2022 was another major step. It introduced Aleo BFT, their custom consensus mechanism.
Aleo BFT. We'll need to unpack that.
We will. And crucially, testnet 3 allowed developers to actually deploy and run ZK programs Aleo smart contracts on the network.
The programmability really coming online.
Right. Plus, they had incentive programs specifically for provers and for deploying applications, really trying to bootstrap the ecosystem.
And all that led up to
the mainnet launched in September 2024. That's when the network went live, and the actual Aleo token came into existence.
mainnet is live. Okay, so for someone coming from, say, Ethereum development, let's get into the weeds a bit. How does Aleo technically achieve this privacy and programmability combo?
Okay, yeah, let's dive in. At the core, instead of just proof of work or proof of stake, Aleo uses something called proof of succinct work, POSW.
Proof of succinct work. Okay, break that down.
Think of it like an evolution of proof of work, but deeply integrated with zero-knowledge proofs.
Exactly. Not just burning electricity to solve a generic puzzle.
Right. In POSW, network participants called provers solve specific cryptographic challenges. These are called coin-based puzzles.
Coin-based puzzles.
Yes. And solving these puzzles generates the zero-knowledge proofs that validate transactions or program executions. The key is they do this without revealing the underlying data.
Ah, so the work is creating the privacy-preserving proof.
Exactly. And for doing this work, they get rewarded in Aleo tokens. And interestingly, this coin-based puzzle they solve actually changes periodically. Every 360 blocks, they call that an epoch.
Keeps things fresh, prevents optimizations for just one puzzle.
Something like that, yeah. It's part of the security model.
Okay, so POSW is how proofs get generated. And these ZKPs, the zero-knowledge proofs themselves, are the real engine here for privacy.
Absolutely. ZKPs are the magic. They let the prover convince a verifier, the network, in this case, that a statement is true.
Like, I have enough funds for this transfer, or this program ran correctly.
Exactly those things, but without revealing any other information. Not the amount, not who the parties are, not the internal state of the program, just, yes, this is valid according to the rules.
That's fundamental for the private dApps you mentioned earlier.
Totally. It's what makes them possible on-chain.
But you still need everyone to agree on the state of the chain, right? Which proofs are valid, which block is next. That's where Aleo BFT comes in.
Exactly. So PSW handles the proof generation, the privacy aspect. Aleo BFT is the consensus layer that provides the security and agreement.
And BFT means Byzantine fault tolerant, like it can handle some bad actors.
Correct. It's a protocol designed so that validators on the network can reach agreement on the order of transactions and the validity of blocks, even if a certain fraction of validators are faulty or malicious.
So validators run Aleo BFT to agree on the ledger.
Right. They essentially vote on blocks proposed, and a supermajority needs to agree for a block to be finalized. It ensures the integrity of the chain.
Okay, so we have two key roles emerging: provers and validators. Let's clarify what each one does and what it takes to be one.
Good idea. So provers, their main job is crunching the numbers, solving those coin-based puzzles to generate the ZKPs.
The POSW part.
Exactly. They get rewarded directly with Aleo, specifically the Coinbase reward for each valid proof they submit. And a key point, you don't need to stake any Aleo to be a prover. Anyone with the right hardware can basically try.
Interesting. So proof generation is permissionless in that sense, too. What about validators?
Validators have a different role. They run the Aleo BFT consensus, they produce the blocks, they verify the proofs submitted by the provers, and they generally secure the network.
Okay, the consensus and security layer, what's required there?
To be a validator, you need to run specific software called Snark OS, and you do need to stake ALUO. There's a minimum self-stake, currently 100 ALUO.
Just 100, that seems low.
That's the minimum self-stake. But to actually be part of the active set the group currently chosen to validate, theoretically capped around 200 validators your total stake, including what others delegate to you, needs to be much higher. We're talking at least 10 million Aleo combined.
Yeah, okay. So there's a significant stake requirement to be in the active validating group. And how are they rewarded?
Validators earn rewards from a few sources: a base reward for producing a block, a share of that Coinbase reward generated by the provers, and transaction fees from the transactions included in their blocks.
So a clear separation. Provers do the ZK computation, validators do the consensus and block production.
Exactly. It's a key design choice in Aleo.
All right, let's loop back to Leo, the programming language. How specifically does it help developers build these private apps? You said it abstracts the complexity.
It really does. Leo is designed with privacy by default as a core principle. Meaning data in your Leo program is considered private, confidential, unless you, the developer, explicitly mark it as public. That's a fundamental shift from, say, Solidity on Ethereum, where everything is public, unless you work hard to obscure it.
Okay, that's a different starting point.
Definitely. And the Leo compiler, which is actually built using Rust, takes your Leo code, which looks somewhat like JavaScript or Rust, an imperative style.
Familiar to many developers, then.
Right. It takes that code and compiles it down into the complex zero-knowledge circuits that the provers then use to generate the proofs. It handles that translation.
Does it have good tooling, like testing?
Yeah, it has built-in testing frameworks, and there's a big focus in the Aleo community on formal verification, mathematically proving that the code does what it's supposed to do, which is super important when dealing with sensitive data and assets.
Okay, so Leo makes writing the code easier.
Yeah.
Where does this code actually run? You mentioned the AVM, the Aleo virtual machine. How's that different from the EVM we know from Ethereum?
Good question. The AVM is Aleo's specialized execution environment. Think of it as the engine that runs the compiled Leo programs.
Right.
One key difference is architecture. The EVM is stack-based. The AVM is register-based.
Why does that matter?
Register-based architectures can often be more efficient for the types of computations involved in generating zero-knowledge proofs. The AVM's main job is to take the program instructions and translate them into this mathematical format called R1CS Rank 1 Construct Systems.
R1CS, that sounds like ZK jargon.
It is. It's the language the proving system understands. The AVM generates these constraints, and then a specific ZK proving algorithm Aleo uses, called Varuna, processes these R1CS constraints to create and verify the proofs.
Okay, so AVM translates Leo into R1CS for the Varuna prover.
Got it. And another really cool thing about the AVM is its native support for something called the record model.
The record model.
Yeah, think of it as how Aleo manages private state on-chain. Data isn't just sitting in a public contract storage. Instead, it's encapsulated in records that are encrypted and owned by specific addresses. Only the owner can decrypt and spend or use that record.
Like UTXOs and Bitcoin, but for general private data.
Kind of analogous, yeah, but programmable. Every node running Aleo runs an instance of the AVM to check that proofs related to these records are valid without seeing inside the records. And Aleo BFT keeps all these AVM states consistent across the network.
So specialized VM optimized for ZK using this record model for private state. That makes sense.
It's all tailored for private scalable applications.
Okay, we've covered the tech layers. Let's talk about the Aleo token itself. What are its main jobs in the ecosystem?
Right, the Aleo token. Sometimes you'll see it called Aleo credits in the code or docs, but Aleo is the ticker. Its main uses are pretty standard for a Layer 1 token, but with a ZK twist.
Okay, like what?
Primarily paying for transaction fees. When you interact with the network or a dApp, you pay fees in Aleo.
Standard.
Also, incentivizing the network participants. We talked about rewards for provers, the Coinbase reward, and rewards for validators, block reward, share of Coinbase reward, transaction fees, all paid in Aleo.
Makes sense. Keeps the network running. Anything else?
Governance. Holding Aleo gives you a say in the future direction of the protocol through voting on Aleo improvement proposals, or ARCs.
Okay. Fees, incentives, governance. What about the supply? How many Aleo are there?
At launch in September 2024, the initial total supply was 1.5 billion Aleo.
And is it inflationary?
Yes, there's a built-in emission schedule. It's projected to increase the total supply to around 2.6 billion tokens over about 10 years.
Okay. And you mentioned fees pay for computation. Is that particularly important in Aleo because ZK proofs are intensive?
Exactly. Generating ZK proofs, especially for complex applications, requires significant computational resources. So the transaction fees paid in Aleo directly compensate the provers for doing that heavy lifting, for running those ZK circuits. It's a market for private computation.
Right. The provers need to be paid for their work. You mentioned rewards earlier. Can we recap the economics for validators and provers?
Sure. Validators get a base block reward for each block they successfully propose and finalize. They also get a cut of the Coinbase reward, the new Aleo created by provers, and they collect the transaction fees in their blocks.
Okay.
Provers, their reward is simpler. They get the Coinbase reward directly for each valid POSW proof they submit.
And you mentioned an update, ARC42. What's that about?
Yeah, ARC42 is an upcoming change focused on inflation. The goal is to stabilize the network's annual inflation rate at a fixed 5%. It plans to do this by adjusting the base block reward for validators dynamically based on how quickly blocks are actually being produced aiming for a target block time.
Interesting. Trying to create a more predictable economic environment.
Exactly, for both validators and the network as a whole.
Now, for regular users or token holders who aren't running hardware, can they still participate in securing the network? Staking.
Yes, absolutely. Staking is a key part. If you hold Aleo, you can delegate your tokens to a validator you trust.
Why would I do that?
Well, first, it helps secure the network. Validators with more stake delegated to them have a higher chance of being selected to produce blocks, making the network more robust. Second, you earn rewards.
Ah, okay. How does that work?
The validator you delegate to earns rewards, as we discussed. They then typically share a portion of those rewards back with their delegators, like you, after taking a small commission for their service.
Is there a minimum amount I need to delegate directly?
For direct delegation to a validator, yeah, the threshold is generally around 10,000 Aleo.
Okay, that's quite a bit. What if I have less?
That's where liquid staking protocols come in. Projects like Pondo, Beta Staking, Staking.xyz, LSP Finance, they let you stake smaller amounts.
How do they work?
You deposit your Aleo with them, they pool it and stake it efficiently, and they give you back a liquid staking token like Staleo or something similar that represents your staked Aleo plus accruing rewards. You can often use that token in DeFi too.
Got it. So, options for both large and small holders to participate. What about governance? How does the community actually steer the ship?
It's done through the ARC process Aleo improvement proposal.
IRCs, okay.
Anyone can write up a proposal for a change or a new feature, maybe a new standard, a protocol tweak, whatever. Usually starts as a draft, maybe on GitHub.
Then what? Discussion?
Yeah, lots of community discussion, typically on platforms like Discord. People debate it, refine it.
And the final decision.
If it gets enough support and seems viable after discussion, it goes to an on-chain vote. Aleo token holders use their tokens to vote yes or no on the proposal via a dedicated voting platform.
So token holders have the ultimate say. Have there been significant ARCs already?
Oh, yeah. We've seen things like ARC20, which is a standard for fungible tokens on Aleo, kind of like ERC20 on Ethereum. There's ARC100, focused on compliance approaches. ARC21 is another token standard proposal. It's an active process.
And who manages this process? Is there a foundation?
Yes, the Aleo Foundation plays a key role. They help facilitate the process, support discussions, maybe fund research related to proposals, but they don't dictate the outcomes. The voting power lies with the token holders.
Okay, a community-driven process facilitated by a foundation. That makes sense. With Mainnet Live and this governance in place, what's the ecosystem actually looking like now? Are people building stuff?
Oh, definitely. It's growing really quickly. Since the mainnet launch, they're reporting over 350 projects starting to build.
Wow, 350. In what areas?
Across the board, really. We already mentioned identity with ZPass. There's compliance tools like Predicate, helping define rules before transactions happen.
DeFi.
Yep, DeFi is active. Decentralized exchanges are popping up: AlphaSwap, Arcane Finance, ShadowFi. And those liquid staking providers we talked about, Pondo, Beta Staking.
What about basic infrastructure like explorers, wallets?
Crucial stuff, yeah. There are several block explorers like Provable Explorer, Aleo123, AleoScan, RPC providers like Obscura offering APIs and SDKs for developers. Wallets are emerging too: Puzzle Wallet, Leo Wallet, Fox Wallet.
Interoperability. Bridges.
That's starting to. Projects like Verilink Bridge and Izar are working on connecting Aleo to other chains like Ethereum.
Even governance tools.
Yeah, things like Z Society, which aims to enable private DAOs, decentralized autonomous organizations where membership or voting could be private. Also private asset trading within those DAOs.
It sounds like developers are really exploring the possibilities opened up by privacy.
For sure. It's a vibrant scene.
With all this activity, especially involving finance and identity, security must be critical. What's Aleo done on that front?
Absolutely paramount. Before Mainnet, the Aleo Foundation invested heavily in security audits. They brought in top-tier firms, Trail of Bits, NCC Group, CK Security to audit the core code, Snark OS, and Snark VM.
And were the results public?
Yes, they published the findings and the fixes. Transparency is key there.
What about ongoing security?
They have an active bug bounty program. They work with platforms like HackerOne and BugCrowd to incentivize security researchers to find and responsibly disclose any vulnerabilities they might discover in the live protocol.
So professional audits plus continuous community vigilance.
That's the idea, a multi-layered approach to try and keep the platform secure.
Okay, stepping back a bit, we've covered the tech, the token, the ecosystem. How does Aleo's overall vision, this HTTPS for blockchain, really differentiate it from established players, especially Ethereum?
Yeah.
What are the unique selling points and maybe the trade-offs?
The core vision, That privacy layer for Web3 is the main differentiator. Aleo integrates zero-knowledge proofs at the absolute base layer. It's fundamental to how the whole thing works.
Whereas on Ethereum, ZK is more often a layer 2 solution or something added on top.
Generally, yes. ZK rollups, for instance, bundle transactions off-chain using ZK proofs for validity, but the base layer wasn't initially designed with ZK as its core execution model. Aleo was.
And the advantage of that native integration is?
Potential for better efficiency and a more seamless developer experience specifically for private applications. That's why they built Leo, the custom language, and the AVM, the specialized virtual machine. They're optimized for ZK computation from the ground up.
Does the user have choices in how proofs are generated?
Yes, that's another interesting aspect. You could potentially generate proofs locally on your own device, keeping everything client-side. Or if it's too computationally heavy, you could outsource the proof generation to a third-party prover service.
Flexibility there. What about trade-offs? Is building everything around ZK complex?
It definitely introduces its own complexities. ZK proofs can take time and resources to generate, even with optimizations. Certain types of computation might be less efficient inside a ZK circuit compared to a more open system. It's a different set of engineering challenges.
So the trade-off is maybe some computational overhead or complexity in exchange for that built-in privacy.
That's a fair way to put it. The huge advantage is that privacy by default stance. It fundamentally changes how you can think about building dApps that handle sensitive information compared to the inherent transparency of a platform like Ethereum.
Okay, this has been a really comprehensive overview. Let's try to summarize the absolute key takeaways for someone new to Aleo.
All right, the essentials. Aleo is a live Layer 1 blockchain. It's permissionless, programmable, and its defining feature is privacy, achieved through native zero-knowledge proofs.
Offering better security, potential scalability for private apps, and confidentiality built in.
Right. Remember the key roles. Provers generate the ZK proofs, POSW. Validators secure the network via consensus, Aleo BFT.
And for developers, the tools are Leo, the privacy-focused language, and the ADM, the specialized execution environment.
Don't forget the Aleo token. It fuels the network through fees, incentivizes provers and validators, and enables governance. And the ecosystem is growing fast, lots of projects exploring private use cases.
And tying it back to that initial analogy, the goal is really to be that missing privacy layer, the HTTPS, potentially unlocking whole new types of applications, commercial, personal, that just weren't practical on fully transparent blockchains.
Exactly. So the closing thought, especially for you developers listening, consider what truly private and verifiable computation enables. What doors does that open? What applications that seemed impossible before might now be within reach? What new things can you build with this?
A really powerful question to end on. If you want to dig deeper, the best places to go are aleo.org for the main project info and leo-lang.org for the developer specifics.
Definitely check those out.
Thanks so much for walking us through Aleo today, and thanks to all of you for joining us on this deep dive.